Okay, so this video is going to be about number bases. So what I mean by that is, for instance, if we write down a number, let's say 217, then we conventionally are using base 10. So what this means is 2 times 10 squared plus 1 times 10 to the power 1 plus 7 times 10 to the power 0, right? That's what we mean when we write the number 217. What about if we wanted to write in, say, base 7? Okay, so let's consider, for instance, the number 341 in base 7. So I'll write this kind of 7 here to denote base 7. Well, this is going to be equal to 3 times 7 squared, right? Because there's a 3 in the kind of the first column of 3, right? And that means raised to the second power, just as we did here, plus 4 times 7 to the power 1, plus 1 times 7 to the power 0. So what's this equal to? So 7 squared is 49, so this is 3 times 49, plus 4 times 7, plus 7 to the 0 is just 1, so this is 1. So 3 times 49, that's like 3 times 50 minus 3. So that's 150 minus 3, which is 147, plus 28 plus 1. So this is equal to 147 plus 28 is equal to 175, and then add 1, and that's 176, I think. So this is equal to 176 in base 10. Okay, so that's how we kind of write numbers in the different form. Okay, what if we wanted to do? So what if I gave you 217, as we did above, and we wanted to know what that was in? Well, let's just, because it's easier. Let's say we want to write 21 in base 10 in base 7. So what's this equal to in base 7? Well, what we need to do for that is we need to have an idea of first how many digits is our number going to have. Okay, so we'll do our working in this kind of green color. So 7 is less than 21. Okay, so that means that it's going to be, this is 7 to the power 1, so it's going to be at least a 2-digit number. 7 squared, on the other hand, is equal to 49, and this is bigger than 21. So if we had a 3-digit number, then the smallest 3-digit number is going to be 100, base 7, but this is equal to 7 squared, which is 49, and that's bigger than 21, so that we know that it can't have 3 digits, but it's got to have at least 2 digits, because if there was a kind of just a 1 here, then that wouldn't be enough, right? So because that would just be 7. Okay, so so we know that it's going to be 2 digits, and so now we need to establish, well, okay, how many times does 7 to the first power go into 21? And of course we know that 21 divided by 7 is equal to 3. So what that tells us is that 21 in base 10 is equal to 3 times 7 to the power 1 with no remainder. So this is equal to 30 in base 7. And then one more example, if we had 22 in base 10, then this is going to be equal to 3 times 7 to the 1 plus 1 times 7 to the 0. So this is going to be equal to 31 in base 7. So this is how the kind of basics work of changing base. Now let's do a kind of funky example. Say if I had the number 123 in base x, then what's this going to be equal to? Well, if we follow the same strategy we've been doing before, then this is going to be 1 times x squared plus 2 times x plus 3, this is x to the 1, times x to the 0. So this is just going to be equal to x squared plus 2x plus 3, right? So in fact what we can do is we can kind of write polynomials in this form. In fact, we can write lots of different things by just having a weird base. This is not a conventional way to do it, but sure you can do it. So one last example, which is maybe interesting, is, well, let's say we have the number 105 in base 2i, okay? So this is where I squared is equal to minus 1, so I is like the square root of minus 1. Okay. So what's this equal to? Well, again, we can do the same thing. So we have this is equal to 1 times by 2i squared plus 0 times 0 times 2i to the power 1 plus 5 times 2i to the power 0. Okay, so 2i squared, that's going to be 4 times I squared. So I squared is minus 1, so this is going to be minus 4 plus 0 times 2i, so this is just 0, plus 5 times 2i to the 0. Well, 2i to the 0 is 1, so plus 5, so this is equal to 1. And so notice that this is actually equal to 1 in base 2i, right? Because this is equal to just 1 times 2i to 0. So in particular, we don't always have uniqueness. So the number 1 in base 2i can be written in at least 2 different ways. We can have it in this way, 105, or we can have it in this way, 1, right? And in fact, there would be infinitely many ways to write the number 1 in base 2i. And there's way more stuff that you can get into with changing bases and stuff, but I thought that was kind of an interesting introduction to the idea.